Not a whole lot. We just took a test today, and that's all we did.
Okay, how'd you do on it, you think?
Uh, I don't really know.
No? No feel for it?
No, because the last time I thought I did pretty good. I practically failed it.
Yeah. Oh well, it'll get better, especially if you keep putting in this extra work.
Yeah.
I guarantee you it will. It might take a little bit, but so was the test mainly on factoring?
Yeah, that's all it was factoring.
Okay. So
Then
what's the next material you're going to cover?
complex numbers.
Okay, let's get a start on complex numbers.
Okay.
That's what I is equal to.
Okay.
Square root of -1. Forget everything else they've told you up until now about not being able to take the square root of negative numbers.
Okay.
It serves a very useful mathematical purpose for higher math to invent imaginary numbers. In other words, there is no number that when multiplied by itself will give you -1.
Mm-hmm.
So that's what I is defined to be. Now,
Okay.
let's go through the first 4 iterations of I. If I is square root of -1, what is I squared?
-1.
Uh-huh. What is I cubed?
Wouldn't it still be -1?
No, it would be I times I squared, so it would be -I.
Huh.
I to the 4th would be I squared times I squared, which would be
-I squared, or?
if I to the 4th is the same as I squared times I squared, which it is, you can add the exponents. And
Be
this, there you go. So those are the first 4, and the reason I covered them is after that they start repeating. In other words, I to the 5th is the same as I, and I to the 6th is the same as I squared. So problems that they would ask you would be, what is I to the 12th equal to?
one? 1?
What is I to the 14th equal to?
1?
It would be this one here, -1.
-1.
In other words, you take out all the multiples of 4. So I'm going to subtract the highest multiple of 4 that I can, which makes it I to the 2. Okay?
Okay.
So a test you might see on a test would be what is I to the 501st power? Well, the multiple of 4 there would be 500. So that's the same as I to the 1, or just I.
Okay.
Okay? Now, everything else about I is pretty straightforward. In other words, if I have 2 plus 3i and I want to add it to 6 minus 2i, this is the real part, this is the imaginary part. And it's usually stated in this format, a plus bi. Okay? So to add these, you add the real parts, and you add the imaginary parts. Pretty straightforward. Same thing with subtracting. Same thing with multiplying. If I multiply this times this, just do FOIL. 312 minus 4i plus 18i minus 6i squared, which becomes 12 plus 14i. What's minus 6i squared equal to?
The 6.
So this becomes 18 plus 14i is your answer when you multiply that times that. Now, the only thing that's really different is when you divide. Let's go through a division. Let's assume that's our problem.
Okay.
We're not really going to divide these. What we're going to do is we're going to make the denominator real. Much like it is incorrect to have an irrational denominator, you'll never see that as a math answer.
Okay.
Because you want a rational number in the denominator, so I would take this and multiply it by root 3 over root 3, and I would end up with 2 root 3 over 3. So this is the way I would show that answer. Same number, but I now have a rational denominator, not an irrational one. Well, by the same token, you never want an imaginary denominator. Okay, so I don't mind having an imaginary numerator, but I can't stand the imaginary denominator. So instead of doing division, we're going to multiply by the conjugate. That's the conjugate.
Okay.
In other words, it's this with a plus sign or an opposite sign is the conjugate. Now, I can do that because 3 plus 2i over 3 plus 2i is 1. And you can multiply any fraction by 1 without changing its value. Now, the beauty of this is when you multiply by the conjugate, notice the middle terms cancel always, and you end up with 9 minus 4i squared. That's plus 4. So you end up with 13 in the denominator. In the numerator, you're going to have an imaginary number, but we don't care. It's fine to have an imaginary number. We're going to have 6 plus 13i plus 6i squared, which is minus 6, so we're going to have just 13i in the numerator. So I've just covered just about everything you need to know about imaginary numbers.
Okay.
Do you have any exercises or problems in the book or anything that looks different than what we just did? Here, solve this equation for me.
Is it I or 1?
Well, first step is subtract 1 from both sides. What's the next step?
Square root of -1, which would be I.
Square root of both sides. That leaves x on the left, and it actually leaves plus or minus square root of -1, which is I. So this is where I comes in, is when you have a equation that's only solution is imaginary numbers. Notice that you can't have x squared plus 1 equal to 0, because without imaginary numbers, this number will always be 0 or greater. It'll be positive. any number squared is positive. So to add 1 to it and get 0 is impossible.
Okay.
So imaginary numbers allow us to come up with solutions to equations that would otherwise not have solutions. Also, if you have a quadratic that you have to use the quadratic formula on, do you know the quadratic formula?
Yeah.
Doesn't.
X equals negative b over 2a.
That's half of it. In other words, what you gave me was just the vertex of a quadratic.
Okay.
Okay? So the full quadratic formula is this. And for a quadratic like that, notice that you can't factor that. There's no factors of 12 that add to 1. So if I'm looking for a solution for this equation, I have to use the quadratic formula. You pretty much have to use the quadratic formula whenever you can't factor it by hand or manually.
Okay.
Okay, so what's b? What's minus b here?
Negative x, or negative 1.
Negative 1. It's the coefficient of those. B squared is 1. What's A?
1.
What's C?
12.
And 2A would be 2. So this thing solves to minus 1 plus or minus the square root of negative 47 all over 2. Now, remember what this is. This is x equals. So I can't really simplify that, but that's not in a plus bi format. Okay? So square root of negative 47 is equal to what? How can I write that in terms of I?
I squared?
No, the way to do it is this. Factor that. In other words, remember that the square root of a times b is equal to the square root of a times the square root of b. So I'm going to take the square root of negative 47 and I'm going to make it equal to the square root of negative 1 times the square root of 47. Like that. And then this is I. So my answer is positive square root of 47 I. And now, if I want to get it into this format, I have to split this up into two fractions. That fraction and that fraction. So my x value really is minus 1 plus square root of 47 over 2, minus 1 half plus 47 over 2i. That's one solution. The other solution is minus 1 half minus square root of 47i over 2. Now that's in this format. In other words, here's the real part of the answer. Here's the imaginary part of the answer. Any questions? questions, or do you have any problems that are similar that you'd like to do? We don't have a lot of time. We got like 13 minutes, but...
Yeah.
Are you understanding it, or... because...
Not really. It's just kind of weird.
It is kind of weird. The best way to explain, I wish I could give you real-life examples of where imaginary numbers are used, and the only one I know of is electricity. If you talk to any electrical engineer or even an electrician, they'll know what imaginary numbers are because they use them to calculate amperage and wattage and what, I don't know what the formula is, but it uses I. So
Okay.
there are practical applications. There's also something called the Mandelbrot series, which uses fractals, which involve complex numbers. And they're also a tool for doing more advanced math. But really, everything you need to know about it, I explained tonight. There really isn't that much to know about complex numbers.
Okay.
Not at your level of math. I mean, when you're taking third level college math, there's a lot more to know about it. But the biggest thing to know is that I is equal to that. If you know that, everything else follows from that. So what is the square root of negative 16?
Negative 16 would be... I don't know.
Break it up into 2.
I mean, negative...
Make sure one of them's always negative 1.
Okay.
So what's the other one?
4 or 16.
Right. In other words, breaking it up into these two things will always allow you to get the answer, 4i. And it's better to put this part in front. You don't want to write it I4. You want to write it 4i.
Okay.
Okay? You know how to do that. That's going to take you a long way. What is the square root of negative 100?
Square root of negative 100. Break it up. Square root of negative 1 times square root of 100.
Okay.
Square root of 100 equals 10i.
You got it. Okay, let me do one more here. How do I solve that?
Once you multiply it by 3 minus I, top and bottom.
3 plus I, the conjugate.
Oh, plus I.
The conjugate means the sign is different in the middle. Okay, and the reason you want to multiply it by a different sign is, notice what happens. Foil this for me. First term?
3 plus I equals 9 plus 3i minus 3i plus negative I or minus I?
Minus I squared.
Minus I squared.
In other words, I times I is I squared, but minus I times plus I is minus I squared.
Okay.
Notice the two middle terms disappear, and this term always turns into a real number. I squared is minus 1. So our answer becomes 9 minus a minus 1, or 10. So when you multiply a complex number by its conjugate, it turns real. And
Okay.
that's what I want to do. I want the denominator to be a real number, and it's 10 now. And the numerator just becomes 6 plus 5i plus I squared, which is minus 1, so it becomes 5 plus 5i. That's the numerator. Don't mind having an imaginary number in the numerator. It's perfectly fine.
Okay.
So treat I just like any letter, any number in terms, when you're multiplying it together, just FOIL it just like you normally would. It's just that whenever you get an I squared, convert that to minus 1.
Okay.
Let's see. This is new stuff that you haven't covered in class yet, or is this stuff you started to cover today? Or
No, this will be tomorrow.
this will be tomorrow. Well, you get a good head start on it.
Yeah.
This should help you. And I really think I've covered every single thing you'll have covered tomorrow.
Okay.
I'm going to be surprised if you get something different. If you do, write it down. Let me know what it is next time we talk.
Okay.
All right. Okay. Well, if you don't have any other problems to cover.
Well, in the book there is one about fractals.
Okay.
It's the fractal at left can be described by the function f of z equals z squared plus c. And if c equals 0.383 plus 0.11i, find the first two output values of the function. Use z equals 0 as first input value.
Okay, notice this function. C is positive. That's always a positive number because z squared is always going to be positive. So it's kind of like the x squared plus 1 that I was talking about.
Okay.
Now, they said, I'm not quite sure I got the rest of it, but and fractals is kind of special. In all honesty, in 5 years, I've only had one person cover that section on fractals that you're covering right now, and it can be a little difficult. I'm not sure I can help you, but I can give this a shot. Let's see. They said C is equal to 0.383, right?
Plus 0.11i.
C is?
Yeah.
C is equal to plus 0.11i.
No, it's the whole thing. C equals 0.383 plus 0.11i. That's all of C.
I get you now. That's in A plus BI format also. Okay. And the original function f of z is z squared plus c. Is that correct?
Yes.
So everything I have on there is right?
Yeah.
And what do they want?
Just find the first two output values of the function and use z equals 0 as the first input value.
Okay. So if I want f of 0, I'm going to substitute 0 for z. So I would have just c.
Okay.
And so f of 0 is going to be this. And the next one is the one that I don't know what they mean. And I might not even be right on this one. I think I am, but you might have to go through an example on that page to figure out how to do a problem like this. I'm sure they
Okay.
give you. I'm sure they give you an example, and that's what I would suggest. I don't have your book, and I don't think I do. Maybe I do. Is your Algebra 2 book Larson, Boswell, Knold, and Stiff? I don't think it is. I think you showed it to me when I met with you.
It's Prentice Hall will be the company.
Yeah, that's the publisher. Mine's McDougall Whitell. So I don't have your book, so I'm not going to have that page.
Yeah, I don't even see an example of how to solve for that. It's just
Really? Well,
there it is.
I think f of 0 is just going to be 0 squared plus c, and they're telling you what c is. So
Yeah.
f of 0 should be that, but when they say the next level, I don't know what they mean by that. But if you go through that example, you might be able to figure it out.
Yeah. Yeah, it's talking about when you get your first output, because we did the first part right.
Okay.
Where that it's just C. But then C becomes your next input value.
Ah, so now we want f of c.
Yeah.
Okay, I know how to do that. Remember that when you're taking a function, whatever is in the parentheses, you substitute for z.
Okay.
So what I have is c squared plus c. And
Yes.
c squared is that squared. So 0.383, how do you square it? I'll show you. You multiply them together.
Just FOIL?
FOIL them.
Okay, that makes
In other
sense.
words, whenever you're multiplying an a plus bi format of an imaginary or a complex number, then you FOIL them, and plus we have added one of them. Nice of them to use the numbers 11 with our I.
Right.
I mean, that's somebody's idea of a cruel joke, I think. So
Yeah.
This must be the second level. If this is the first level, this would be the second level. And then the third level, I believe, is where you put in that answer.
Yeah, the second output becomes third input.
Right, right. Yeah, I kind of remember that. I don't know what that produces relative to fractals, but maybe that produces each branch. The definition of a fractal is it looks the same no matter how much you zoom in or zoom out. In other words, if you were to look at a coastline from a satellite and you zoom in on it, it still has the same jaggedness as it looks from 100 miles in space. And if you keep zooming in on it, it still has that same jaggedness. So when they talk about fractals, that's kind of what they're talking about. And a lot of things kind of have that. Mountains tend to have fractal. You got to use fractals to have a computer do a proper job of drawing mountains. In fact, I'm sure they use fractals in a lot of the video games because that's the only way you can draw some of that stuff by a computer. All right. So I guess our next session is going to be Monday night at 8, and we're going to do 30-minute sessions Monday, Tuesday, Wednesday?
Yeah.
Okay. Sounds good. I will text you the meeting ID next Monday.
Okay.
All right, Silas. Have a good weekend.
You too.
Bye-bye.